So we're recording the session and we'll make it available on our website afterward. So again, thanks everyone for joining. My name is Rick Berkey. I'm the Director of Global Campus and Continuing Education here at Michigan Tech. This session's scheduled for an hour and we'll be talking about the online Master of Science in Civil Engineering program and related graduate certificates that we have available. We'll have plenty of time for questions at the end. But if you do have a question along the way, you can use the chat feature in Zoom. And to get using that chat feature with a bit of an icebreaker, I'm going to ask Amanda Irwin, our graduate admissions manager, to post a question to the audience. And I'll hand it over to you here briefly. Amanda, go ahead.
Good morning. Thanks for joining us. We were just curious this morning if the weather was nice where you're at and where you're joining us from. So I'm going to put that question in the chat. If you are familiar with Zoom, there's usually a tray of options at the bottom of the just below the presentation that you're seeing. And as we go along, we'll stop periodically to answer questions. So just pile them up here in that chat and we will get them addressed. So I'm joining from Midland, Michigan. I work remote for the university and it is not raining. So I'm happy about that today. And with that, we'll just go ahead and get started with our session.
All right, thanks, Amanda. Yeah, and while you're posting the chat and letting us know what's going on there, I'll go ahead and cover our agenda here briefly. So we'll do some introductions on our side, provide an overview of Michigan Tech for those that may not be familiar with the university. Then we'll lead into the substance of the program here today, talking about the online civil Master of Science. And I would say, importantly, some of the unique differentiators and points of pride that we want to emphasize as well. We'll close with a review of the application process and next steps for those that might be interested in taking that next step. And we'll, like I said, leave time for questions at the end. As far as introductions, I had introduced myself, but again, Rick Berkey, Director of Global Campus and Continuing Education. So presenting with me today are Dr. Andrew Swartz. Dr. Swartz is an associate professor and also department chair for our Civil, Environmental, and Geospatial Engineering department here at Michigan Tech. And then Amanda Irwin, our graduate admissions manager, who kicked us off here with the icebreaker. We also have Shelly Gallia. She's our marketing and content manager for Global Campus. Shelly's going to help monitor the chat. Shelly also helps set up these events on the back end and front end. So getting us here today with all the details that go with that. So let's go ahead and get started. So I want to start by just giving you a little bit of background on Michigan Tech. Some of you may be alum, but if you're not an alumnus of Michigan Tech, here's a little bit of background. So we were founded in 1885, so we've got a 140-year history going here as a public research university. For those that know a little bit about Houghton, Michigan, and the area where Michigan Tech is, it was a copper mining area of focus back in 1885. So that was really the starting point for the university. It was metallurgy, mining, engineering, and technology. It was originally founded, in fact, as Michigan Mining School. If you fast forward 140 years to today, we're now an HSTEM focused university. That means health, science, technology, engineering, and math. So we have a full range of educational programs and research activity across the spectrum of HSTEM. And as of February of this year, the R1 designation there on the slide, we're now an R1 university, which is the Carnegie classification of institutions of higher education. So what that means is it formally places Michigan Tech among the top research universities in the US. So we're one of about 187, I believe, out of more than 4,000 nationally to be able to earn this designation. And it's based on Michigan Tech's continued growth in research activity and the number of doctoral or PhD degrees that we award each year. In terms of size of the university, we're currently about 7,400 students. That includes both graduate and undergraduate. Roughly 80% of that would be undergraduate programs, 20% graduate. I would emphasize too that for us, we're in a good place where both of those continue to grow year over year. We have 5 colleges with over 140 degree programs. So the colleges include business, computing, engineering, forest resources and environmental science, and sciences and arts. Now, I would say most recently on this slide, Global Campus. So the group that I'm in, we are the home of more than 40 online degree and certificate programs. Again, fully available asynchronously online. So over the past few years, that's been a focus area of Michigan Tech. And here we are today to present one of those programs to you. With that, it's my pleasure to turn things over now to Dr. Andrew Swartz to get us into the online civil program in further detail. So Dr. Swartz, thank you.
All right, thank you, Rick. So I want to talk a little bit about the online programs that we have in civil and geospatial engineering here at Michigan Tech, and what's unique about them, what we really created them to do for students. So next slide, please. The idea is that we wanted to really create an online program for students that was very impactful for them, that relies on the experts that we have as our mainline faculty within the department, that meets the needs of kind of working professionals who are most of our students are practicing engineers now, but they are looking for some additional credentials or education to help them take the next step in their careers. Some of our students are working in other areas and are looking to break into civil engineering areas. And what we really wanted to do was to create, really high quality online courses that were designed for the online space. So they weren't just like correspondence courses or lecture capture, that they really were good use of our students' time. If you're going to carve out time in the evenings for many of our students to do these, we wanted them to be, quality courses. So next slide, please. An example of one of these courses we can sort of see here. This is one of my courses, the Advanced Structural Timber Design course, 5233. They are designed to be fully asynchronous courses, which means that students can work kind of when they have the time. There are not set meeting times. There isn't a period of time during the day or during the week where you're required to be there. They're essentially built around, most of them are built around weekly modules. So you have a set number of lessons and assignments that should be done during the week for that course. But the students can kind of pick when they can get things done as long as they meet those weekly deadlines. So the courses are designed with kind of a mix of kind of videos that you would watch that have lecture as well as example problems. Each course is a little bit different. I like to pace mine for about 3 lessons a week. The videos are relatively short and to the point. They're built around individual topics rather than we're not trying to make you sit there for an hour like you're in class. That's not really how people engage with online content. We're trying to make it kind of shorter module, bite-sized pieces of information, and then make it very easy for you to go back and rewatch things if you need to get them, or you can go through at a little faster pace if there's content that you're already somewhat familiar with. But in the lower left, you can see a typical weekly module design with 3 different lessons. There are also some very low stakes formative quizzes between those lessons. They give you a chance to kind of practice doing some problem work, get immediate feedback from from the learning module on what you've done, retake the quiz if you want to capture the points. And then you should be ready for the homework assignment, which the homework assignments are usually built around, problems that they'll look very much like industry design or analysis problems that you would do kind of in industry. So, you get kind of regular feedback both from self-testing, built-in modules, as well as more complete feedback from the instructor on the homework assignments, and then the occasional exam for really high value topics that you might need. Next slide, please. In the civil engineering department, we're civil, environmental, and geospatial engineering. We have all of the traditional areas of civil and environmental engineering, as well as geospatial surveying. But we haven't put all of them online. We have targeted kind of the areas that we see as kind of providing the most value for students, where we thought we might have the most response from students. So we offer an MS in civil engineering degree online, but the coursework is really focused in either structural engineering, water resources engineering, or geospatial engineering. This is where we've put our early focus, and we have programs we can offer today. So for all of these areas, there's kind of a differentiator in having either a graduate level certificate for some small amount of additional knowledge in this area, or the full master's degree that will allow you to kind of take the next step in your career. For structural engineering, it is, to work in like the medium rise, high rise building design, a lot of bridge design, or, national and international scope companies. Many of them like to hire at the master's level. So we do see that there's some value there. We also try to design our program to support students that wish to pursue SE certification and be able to do well on the SE exam. Water resources is kind of similar. There's a lot of specialized work that and national and international scope companies, as well as government agencies, that are looking for kind of master's level water resources work. And in geospatial engineering, kind of moving into a lot of the advanced digital topics for forestry, petroleum exploration, public utilities, and infrastructure. There's a lot of value that we see for master's level credentials for our students. So we've worked to put adequate coursework for geospatial and surveying students into our online program as well. Next slide. So I'll talk a little bit about what the programs that we have look like within our department for our graduate online programs. We'll start with the structural engineering first. So that is our one that we've had the longest, but we'll be focused on these structural engineering programs, which are broken up between advanced analysis as well as the advanced code-based design courses. Water resources engineering, which are focused around design of water systems, flood prediction, as well as restoration of natural systems. And then geospatial, like I said, the modern tools are kind of the focus for the online program: LiDAR, GIS, hydrographic modeling or mapping, and remote sensing systems. So on the next slide, we have the structural engineering, which is probably our most robust online program we have. All of our MSCE programs that we offer, either on ground or online, they have the same requirements, but kind of what they look like as you work your way through it are a little bit different. But they all require a minimum of 30 credits. Our courses tend to be 3-credit courses, so you're thinking about taking 10 courses to finish one of these programs. At least 18 credits must be at the 5,000 level or higher, but you can take up to 12 credits, 4,000 level, or even 3,000 level if those courses are useful to you and if they are online. We also require for our Higher Learning Commission accreditation a systems course, which is kind of it's really an applied math course that cuts across the department. For structures, that is generally 5730, which we offer online every year. This is a probabilistic and a reliability course that's focused on better understanding natural hazards. And we assume that our students are coming into the structural engineering program with a basic structural analysis background, so statics, mechanics and materials, and really ideally a undergraduate structural analysis course at Michigan Tech that would be CEE 3202 or some equivalent. Many of our students will come in from civil engineering. If you have an ABET accredited bachelor's degree in engineering, generally that will have you on track for being part of our structures program or any of our programs. Though you may want to talk to us a little bit if there is some leveling that you might want to do, like that CEE 3202 course if you're coming from a non-civil engineering, engineering background. If you're coming from outside of engineering, we have some leveling requirements. You'll find on the website this information for what prereqs you should take. Some of these courses you can find through Michigan Tech Global Campus. They will be undergraduate courses that you would need, basic calculus, physics, statics, mechanics, and materials. Some of the other ones are a little bit harder to find, like the CE 3202, but to get you ready for our program, if you happen to be coming from outside of engineering, every single applicant would look a little different. So I would encourage you to get in contact with our departmental coordinator or the grad school, and we'll find you an academic advisor to talk to. So next slide. Our online offerings for the structural engineering focus, most of our structural engineering students, they want to take the structures courses. We offer courses in fall, spring, and summer. Ideally, students that are working full-time and our part-time students are taking one course at a time. So we do offer courses during the summer in order to kind of help you to work your way through the degree a bit faster. It is a little bit slower if you're taking 10 courses, only through fall and spring. So you can see our offerings here. They're also online as well. But these are kind of mainline structures courses. There are about half of them are advanced analysis courses, and about half of them are the code-based structural design courses. And then in fall, keep your eye on that required systems course, the analysis and reliability course. That one is a good one for the structure students. We can fit in other courses as well, other graduate courses in particular, depending on a student's interests. But many of our structures courses, our students really do like to pull from the list on this slide here. Next slide. Besides the full Master of Science option, in structures we have about 5 different graduate certificates, and these are growing in popularity. Most of these certificates are assuming that students are coming in having a little bit of undergraduate structural analysis background, essentially Structural Analysis 1, which is that CEE 3202 course at Michigan Tech. But then we have these, you can think of them as 3-course graduate certificates, and they do include some undergraduate courses in some cases. One of them is focused on analysis. So we have an advanced analysis course for students that are looking for, say, finite element analysis, nonlinear analysis, or dynamics. We have one that's focused on building design, which essentially includes a lot of our code-based structural design courses. We have one on hazard analysis, particularly for students that want to get into performance-based design, which is kind of a new area within the profession. These are very useful courses for that. We have a bridge analysis and design course, and then our analysis and design certificate, and then also a timber building design. We're one of very few universities in the country that have multiple timber design courses, so there's a certificate that you can pursue there. On the next slide, we can see that the idea behind these certificates are that they stack. So if students want to take a certificate and be done, if that's enough for them for their career goals, that is something they can do. but they can take one certificate and then another and even, you know, 3 different certificates and, you know, that would be 9 of the 10 courses that you would need for the full master's degree. And there are various ways. This is just one example on this slide that we can try to stack these credentials. You can kind of add them to your resume as you work your way through the program. But then by the end, by the time you've taken the 10 courses, you can have the full MSCE with the structures emphasis. So next slide. The Water Resources program is pretty similar to the Structures program. There's not quite as many course offerings, and we only have one certificate here, but many of the requirements are the same. So we're looking at about 10 courses that are focused on water resources engineering. We're expecting students to have some basic undergraduate background in fluid mechanics, hydraulics, and hydrology, kind of working their way through what we have as CEE 3620 or equivalent. That's our undergraduate water resources course. Again, there's the minimum requirement for 18 5,000 level courses and at least one systems course. Probabilistic analysis and reliability is offered every fall. And about every other year in the spring, we also have optimization methods, so which can satisfy the systems course requirement instead. Graduate students at Michigan Tech can essentially sign up for courses that they are interested in, but they should talk to an advisor, making sure that they have appropriate prereqs. That's true for this program as well as for the undergraduate program. And again, if you're coming from outside of civil engineering, and if you're coming from outside of engineering in particular, you should have a discussion with an academic advisor when you apply. Make sure that we have appropriate prereqs worked out for you so that you can be successful in these courses. Next slide. Water resources courses, there's not quite as many. You'll see that the summer isn't quite as populated, but we have generally water resources courses. We have some of the river floodplain analysis courses, and then, you know, hydrology and water resource design courses as well offered. This plan here shows the probabilistic analysis and reliability option, but the optimization option is another option. And then again, there is an opportunity to fill in non-water resources courses if it helps with the students' career goals. Students sometimes are looking a little bit outside of that specialty area, and we can certainly support that as long as the course is online. Next slide. We only have one water resources certificate right now. It's a Water Resources Engineering Resilient Water Infrastructure certificate, and essentially you would take 3 out of the 4 courses listed here to you know, be able to show your background in resilient water infrastructure analysis and particularly design. On the next slide, we have our geospatial program. Again, geospatial it's a BS in civil engineering, so it has the same requirements. So roughly 10 courses, but 30 credits. Should have a basic background in undergraduate surveying, mapping, GIS, and remote sensing. 18 credits at the 5,000 level or higher, and we do require one of the systems courses, either probabilistic analysis and reliability or the optimization methods, and should have a similar conversation about prereqs if you're coming from some program other than, you know, a surveying or geospatial engineering program. We'll definitely make sure that you have an opportunity to talk to an academic advisor as you are applying to the program. Next slide. Our course offerings here are kind of similar to the water resources here. We have these offerings in fall and spring. There are some additional courses that you might mix in, including some of the water resources offerings in order to reach the 30 credits. On the next slide, there is a certificate as well that is related to geospatial engineering. It's the Advanced Photogrammetry and Mapping with UAS certificate. You would take 2 required courses plus an elective. And then if you wanted to stack that as, part of the MSCE with geospatial engineering, then you would find an additional 18 credits of your choice plus at least one of the systems courses to fill out the 30 credits for the MSCE. So you're looking at the online information. There's a lot of course names and course numbers here. There's no way you're tracking this in real time, but you'll be able to see it in the online information. You can see these are the types of courses that we have available in the geospatial area. Now, next slide. One other course to make you aware of is that we do have CEE 5390. It's a civil asset management course. It doesn't fit neatly into the structures, water resources, or geospatial bins. It's kind of a construction engineering course. But many of our students find it useful, particularly if they are targeting management in the civil engineering domain. This is a very useful course that we have available online, and you can get a external certification from IAM. So this isn't one of our Michigan Tech graduate certificates. It's a IAM certification, but if you take this course and get a B or better, you can have a certificate that shows that you have this background in asset management. And this has been gaining in popularity with our students kind of throughout the department. They find value in this asset management background. The next slide. Yeah, so student experiences in the online MS program. I'll talk a little bit about that on the next slide. I have some quotes here from some of our previous students that we've had. I guess the first one and the last one are some of my students that I've had in the structures program. But what students appreciate is that it is very driven. The program is very driven by the needs of industry. A lot of what we have in the coursework material, I think students find is very immediately useful for them, and that we really did put a lot of time and effort into the design of the online courses, trying to make them useful for students, make them it's graduate level engineering coursework. I don't want to say it's easy, but it is well organized, generally well laid out to make it as convenient as we can, particularly for students who are working, in this asynchronous mode where they're coming in at whatever time they have free to get some work done. Next slide. Okay, so I think that is my portion.
Thank you, Dr. Schwartz. I can talk through our next steps now. That was a ton of really good information about our program. If it's something that you want to move forward with, there are a couple of start dates coming up, and we can talk through those here. So our fall semester begins Monday, August 25th. And believe it or not, there is still a little bit of time to get your application in if you want to get started for the fall. I would say get started sooner than later and be in touch with me so I can help throughout the process. I work really closely with the department here, and we can usually get admission decisions turned around very quickly too. So spring semester application is also available. Spring semester begins January 5th, and there's plenty of time to prepare for that. What are those next steps? So how to apply? First, you'd have to create an account in our application portal. And so that would require an email address and a password, and you'll set up an account. Then you'll insert an application. You'll select the program of study that you're interested in. So certificate or master's, and then which area in that master's, and then hit submit on the application. After you submit your application, there's going to be an admissions checklist that populates in the application portal that you created. And that's where you're going to upload supporting documents. So typically supporting documents would include transcripts, resume. There's a student statement and a personal statement that you have to write. And then depends on the program, but there may or may not be references required for it. And then once all of that is checked off in the list, your application is complete. We move it forward through the review process. Again, those decisions can come back really quickly. And then I would work with you on next steps and how to get registered and who your contact person is, all of those things before the semester begins. So in any event, if you have any questions specific to you about your education background, about these programs, I'm usually a good first point of contact to kind of talk through those things with you. Link in my calendar should be shared in the chat right now. That is connected real time to my Google Calendar, so it shows my availability. Do a Zoom appointment like this that we're on. You could do a phone appointment. If you have another platform that you're more comfortable with or you use through work or something like Teams, you're also welcome to schedule something and send me a link, and I'm happy to join you on your preferred platform too. But we can talk in detail about your, like I said, education background. We can talk about costs. We can talk about all sorts of things in that appointment. And with that, I think I'll hand it over to Rick.
Yeah, thank you, Amanda. And thanks again, Dr. Swartz, for covering a lot of great information on this program and the next steps. Here's just a final concluding slide here with some contact information for you. So Dr. Barbara Dye is the graduate program director. She couldn't be available today to help us. She's traveling, but she's a good point of contact on the program side. And as Amanda said, Amanda can be a good first point of contact to just help you get started. Angela Karanen also helps Barbara as a graduate program assistant. So both Angela and Dr. Dye are in the Civil and Environmental Geospatial Department. Direct contacts with information here for you should you want to reach out to them. We're done with the formal presentation. So what I'm going to do is stop recording, but we have plenty of time here for questions.